So we have two questions from Jamb concerning what we did. The first one says, calculate the temperature change when 500 joules of heat is supplied to 100 gram of water, taking the heat capacity of specific heat capacity of water to be 4,200 joules per kilogram per Kelvin. Option A says 12.06, 12.1 degrees Celsius. Option B says 2.1 degrees Celsius. Option C says 1.2 degrees Celsius. Option D says 0.1 degrees Celsius. JAM 2012, number 22. Calculate the temperature change when 500 joules of heat is supplied to 100 gram of water, taking the specific heat capacity of water to be 4,200 joules per kilogram per Kelvin. For us to solve the first one, solution, we all know the formula for quantity of heat. We say that quantity of heat is equal to mass MC change in temperature, mass of the substance times the specific heat capacity of the substance times change in temperature of the water. I would say that the quantity of heat is the amount of heat required to raise the temperature of a substance. And here, the substance we're talking about is water because they gave us the specific heat capacity of water. So to solve this question, we say quantity of heat is 500. They gave us quantity of heat to be 500 joules. So it's taking 500 joules to be able to raise the temperature of this water. They said find the calculate the temperature change. So they're asking us what is the temperature, what is the temperature difference. So we said that the quantity of heat is equal to 500 joules. They gave it us. They gave us the 500 joules here. They gave us the 500 joules, and they gave us the mass. They gave us the mass in grams. Note, whenever they give you mass in gram, always convert to kilogram because gram is not the unit of mass. It's not the fundamental unit of mass. Kilogram is the fundamental unit of mass. So for us, it's not the SI unit rather. Gram is not the SI unit of mass. Kilogram is the SI unit of mass. So we have to convert gram to kilogram. We have to convert gram to kilogram. To convert 100 gram to kilogram, we divide both sides. We divide this one by 1,000 because this kilo means 100. This kilo means 1,000. So we say 100 divided by 1,000. 0 cancel 0, 0 cancel 0. We have 1 over 10 now. 1 over 10 equals to 0.1 kilogram. Now we have converted our mass now to kilogram. So our mass becomes 0.1 kilogram. 0.1 kilogram. So we'll be working with 0.1 kilogram. Now the next one is the specific heat capacity of water, which they gave us to be 4,200 joules per kilogram per Kelvin. Calculate the temperature change. We don't know what the temperature change is. We don't know what our change in temperature is. So we call it X. Our temperature change is X. Putting this whole detail, we have gotten our parameters out. So we have to like fix them into this formula. So we say 500 because Q is equals to 500. Q is equals to 500. We say 500 equals to 0.1 kilogram, 0.1 kilogram, which is the mass times the specific heat capacity of water, which is 4,200 joules per kilogram per Kelvin times X. We are saying the change in temperature to be X, and we don't know what it is. They're asking us to find the change in temperature. When you 0.1 times 4,200, this will give you 420. 420 times X. 420 times X is equal to 420X. So we say 420 420x. Remember, this is our 500. For us to get x now, we have to make it subject of the formula by dividing both sides by 420. So 420 cancel 420. X now becomes 500 over 420. X is equals to 420 by 500 will give you 1.19. 1.19. Change in temperature is equals to 1.2 degrees Celsius. So this becomes our change in temperature. So we have to go to the option to change. So C is our answer. This is our answer. Now, for the second question, it says two liquids X and Y have the same mass. Two liquids X and Y having the same mass are supplied the same quantity of heat. If the temperature rise in X is twice that of Y, the ratio of the specific heat capacity of X to that of Y is A 2 is to 1, B 1 is to 2, C 4 is to 1, D 1 is to 4. This is a simple question but tricky. Now, for us to solve this question now, they said two liquids, X and Y, having the same mass. They are having the same mass. The two liquids are having the same mass. So we know that their masses are the same and having the same quantity of heat. The quantity of heat here, which is Q, are the same. M here is the same. The two liquids have the same mass and they have the same quantity of heat. If the rise in temperature in X is twice that of Y, the ratio of the specific heat capacity of the ratio of the specific heat capacity of X to Y is what? So they're asking us what is the ratio of the specific heat capacity of Y to that of X to that of Y. Sorry. For us to solve this, it's easy and tricky. For us to solve this, we bring out, remember our formula here. Our formula which says quantity quantity of heat is equal to MC change in temperature. But now we have two substances now. We have two substances here and there are two liquids. So we are dealing with two substances because we are doing, remember the formula that we said quantity of heat lost is equal to quantity of heat gained. So we are using the same formula here now, but we are trying to be somehow with it. It's not tricky, it's easy. Follow me, let's just do it. So we say quantity of heat loss is equal to quantity of heat gain. They didn't tell us which is losing and which is gaining. They said the both liquid has the same quantity of heat and they have the same quantity of mass. But we're going to still borrow this formula here. So we say Q of X is equal to quantity of heat of X is equal to quantity of heat of Y. Opening, expanding Q now. Remember Q is MC change in theta. So we say mass of X times the specific heat capacity of X times the change in temperature of X is equal to mass of Y times the specific heat capacity of Y times the change in temperature of Y. Now, they said the masses are the same. They said they have the same mass and they have the same quantity of heat. So, because everything here is still the same thing as the quantity of heat, that is why we are having Qx is equal to Qy. Now we have to expand the equation for us to be able to cancel out our mass. So because they said the two liquid has the same mass, we cancel out our y. We cancel out our mass, sorry. So we cancel out mass. So we'll be left with the specific heat capacity of X and times the change in temperature of X is equal to specific heat capacity of Y times the change in temperature of Y. But then again, they asked us, but then again, they said that the where is it again? Two liquids X and Y having the same mass and supply the same quantity of heat. If the temperature rise in X is twice that of Y. Now this is where our concern is. They said if the temperature rise in X is twice. So meaning that the change in temperature in X is two times that of Y. It means that the change in temperature of X is twice that of Y. That is change in temperature in X is equals to two times change in temperature of Y. So anywhere we see change in temperature for X, we put two times change in temperature of Y. So we go down to our equation again. We say specific heat capacity of X bracket, because we are substituting this one for this one. So we say the specific heat capacity of X times 2 change in temperature of Y is equals to Cy, which is specific heat capacity of Y times change in temperature of Y. Now you remember the question, it says what is the ratio of the specific heat capacity of X to that of Y? We'll cancel out change in temperature Y because we have light times here. So this will cancel this one out. So it will cancel this one out. So we'll be left with specific heat capacity of X times 2 is equals to specific heat capacity of Y. So we say Cx times Y will give us 2Cx is equals to Cy. Now, because they said what is the ratio? Now, the specific heat capacity of Y is now 2 times that of X. You get? Now, the specific heat capacity of Y here now is now twice that of the specific heat capacity of X, just like what we did here. We said that the change in temperature of X is twice that of change in temperature of Y. So the same thing we're applying here now. So now it means that this change in temperature of Y is twice, is 2 times, and the change in temperature of X now, sorry, the specific heat capacity of Y is now twice that of X, and the specific heat capacity of X now is 1. Because they said, what is the ratio of the specific heat capacity of X to Y? So because they're saying X to Y, you bring X first. What is the specific heat capacity of X to specific heat capacity of Y? So now the specific heat capacity of X is 1 and that of Y is 2. So the answer becomes 1 is to 2. So we have to go to our option and B is our answer. This is very easy. Just know your maths. It's tricky. Sometimes Jamb can be tricky with their questions, but this is very easy. So this is our answer. Just make sure you know your formula. Once you remember, master this formula, just have this formula in your head. It will definitely help you. Thank you.